Howdy, folks. Welcome back. Let's take a look at 28. It's another one of those job problems. A carpenter can complete a job in 7 hours. After working on the job for 3 hours, so they've completed 3/7 of the job. That's the thing that we got to keep track of. In these problems, a lot of times one of the workers is going to do a fraction of that total job already. So use that time with their work rate to find out how much it is. And we'll do the math here to put the numbers down to what I just said. But if it takes us 7 hours to complete a job, and if I work for 3 hours, I've completed 3 out of the 7 of those hours needed for the job. Okay. Now, eventually an assistant is going to help the carpenter, and together they complete the job in 2 hours and 5 minutes. And the question is asking, how long would it take the assistant if they were to work alone to complete a similar job as this one? So essentially, if they had told us, okay, the carpenter can complete a certain job in 7 hours and the assistant completes the job in 4 hours, that's essentially what they want us to find out. Okay? Alrighty. So let's go ahead and go off to the side here and keep track of a couple of things as we do our work. So number 28. So the speed of for these problems, the speeds at which they work, a lot of times speed is distance over time. Now the distance in this case is really the job. Okay? So don't get too hung up on distance here, so to speak. Because all rates, it's some quantity over the time is going to tell us how quickly we get that job done, or that thing done. Okay? Now, at the end of the day, the speed of the carpenter is going to be one job every 7 hours. It takes him 7 hours to complete the job working alone. Now, we don't know the speed of the assistant. Now, they want us to find out how long would it take them to work alone. How long would it take them if they were working alone? So the time here, right here, this is how much time they take to do the job on their own. Now, we don't know the value for the assistant, so we're just going to write that as X. Okay? So the job is going to be completed by the carpenter at a rate of 1/7. And the assistant is going to complete the job at a rate of 1/X. We're going to have to solve for that X. All right. So at 3 hours, right? So the distance of the carpenter, if we wanted to go through it thoroughly, it would be the speed of the carpenter times the time. Now the speed of the carpenter is going to be one job every 7 hours. And the time we're working for is 3 hours. So the distance that the carpenter completes, or the job, is going to be 3/7. Oops, I miswrote there. 3/7 time of the job, of the job is done by a carpenter. So the remaining amount is one job. Oh man, the pen is getting all over the place. One job minus the amount done by the carpenter minus 3/7. Okay. So at the end of the day, 4/7 of the job is what remains. Now, that is a distance. And distance is speed times time. So here the speeds are going to be the speed of the carpenter times the time he works, plus the speed of the assistant times the time he works at the same time as the carpenter to get this job done. Now, in the question, they tell us that they completed the job 2 hours and 5 minutes after starting to work alone. So the solution, and I really apologize for that. I was really sloppy during mentoring, but I completely ignored that time. And I said it didn't matter, and I completely led you guys astray. I am so sorry. I was doing some of these solutions, and I got all mixed up. Anyways, I know I'm overly apologetic. Let's move on. Okay, so putting this together, 4/7 is going to equal the speed of the carpenter, 1/7 times the time, which is 2 hours and 5 minutes. So we'll take the 5 minutes, we'll convert it to an hour, and then we'll add it to the 2. And so that should be 2.08 hours right here. This would be jobs per hour times hour plus 1 over x times 2. Now I am dropping some of the decimal places because 5 divided by 60 should be like 0.0833 or something like that. But I'm just writing it here to 3 significant figures. But keep the entire precision in your calculator. Okay, so what does this start to look like? 4/7 equals 1 over 7, and I'm going to put that in parentheses, plus 1 over x, and I'm going to factor out the time, 2.083 hours. So we'll take the 4/7, we'll divide over that time, then I'll do 7 inverse, and I'm going to subtract it, and I get 0.131 equals 1 over x. And so the last thing we do is we invert it, and then from there we get that x is 7.61 hours. Okay. The tricky thing here is if you could throw this into the solver. And so how do you do this quickly on the calculator test? Okay, you read the problem and you process. Okay, they worked for 3 out of the 7 hours. They've done 3/7 of the job. 4/7 of the job remains. Okay, speed is going to be 1 over the time for these. So 4/7 equals 1 over the 7 hours plus 1 over x. All of that times the time they spent working together. You divide over the time and you solve for x. A lot faster than I explained it, but hopefully the explanation here, makes sense. Thank you all. We'll see you for the next one.